here just I will try to convert this standard form, that means x plus io form, into another form which is we call here the polar form, right? Dear student, I think all of you know this Cartesian system, right? This is y-axis, this is called x-axis, this is origin, right? I think all of you are familiar with this Cartesian system. Here this horizontal line here gives the values of x, right? And this particular line gives the values of y here, right? So this number, if we consider x plus ioi, so this complex number we can write like this way, right? So now you see here, this is the real part, this is the imaginary part. So if we replace this x-axis or on this x-axis, if we put the real values of the complex number, that means if we put the values of x only, values of this real part here, then this axis here we call real axis, right? This is called real axis. Why you call real axis? Because in this horizontal line just I will put the real part of this complex number, and similarly in this y-axis, on this y-axis just I will put the imaginary part of this complex number, right? That means this axis gives the imaginary value, so that's why we call here now this is imaginary axis. So now we have two axes similar just like x-axis and y-axis, but here we call this is real axis and this is imaginary axis, right? Then what happened here, you see, then what happened, then we can easily plot any complex number on this system. Here you see, suppose if we consider 2 plus 3i, this is the complex number, so we can easily plot this one. You see this thing, this complex number we can write like this. So what is the value of this real part here? 2. So here will be 2, right? And imaginary part is here 3, so 3. So I think this will be the point whose coordinate or whose values will be 2, 3, right? That means this complex number we can easily plot this system. And similarly you see here for any point, suppose if we consider here on points is there, then we can easily find the real part and imaginary part of this complex number. Okay, here you see for this point what will be the values of x? This is -2, so that means -2 will be here x, right? And what will be y? Y also will be -2. So what will be the corresponding complex number? This will be -2 or -2i, so y. That means each point of this plane or of this system will represent a complex number. So from this figure I think it's clear that for any complex number we can easily plot on this system, or for each complex number we'll get a point on this complex number, or each point of this plane will represent a complex number, right? I think it's clear now. That means here you see, since each point of this plane will represent a complex number, so that's why we call here this plane is an eigenplane or complex plane. So you don't forget about the name of this plane, right? So this plane is called here complex plane. Now now the question is that what will be the polar form? Here you see, here we consider x plus iy is a complex number, and suppose we consider this is the point, this is the complex point here, right? And then it's clear that this value, right, this value, what will be this value, guys? This will be here x, and what will be this value? This will be y. And this is the actual complex number, this one, z equal to x plus iy, and we consider this distances, that means from the origin to the complex point is r, and we consider this line OP line makes angle theta with the positive direction of x-axis. If we put this thing and you consider this is m, then from this triangle here you see they will form a OP and M. This will be a right angle triangle. So from this right angle triangle, we can easily find the sine theta and cos theta, right? What will be sine theta here? Sine theta, you must remember, sine theta is perpendicular by hypotenuse. What is the perpendicular here? This is perpendicular, so perpendicular is y. What is hypotenuse? Hypotenuse is r. So here from we will get y equal to sine theta. And similarly, what will be cos theta? Cos theta is based by hypotenuse. That means this will be x upon r. So from here x will be r of cos theta, right? But here you see we have the original complex number z equal to x plus I. This is our complex number, right? So just you replace this x and y by using this one. What we get? Here will be r of cos theta plus r of sine theta will be there, right? So from here we can easily take common r, so this will be I of sine of theta, right? So this is our z. Now you see in this form here, in this z or in this expression here, you see no x and y are present, only r and theta is present and I is present, right? So this is another form of this complex number, and which is called here actually the polar form of the complex number, right? And here this polar form of this complex number here, this r is called here, this is called modulus. This is called modulus of this complex number, and it is denoted like this, mod of z, right? And this theta is called argument, right? This theta is called argument of z, or simply we just denote like this, argument of z, and argument of z is nothing here, theta. But you must remember here, what is theta here? This theta is nothing, this is the angle which made by the line OP with the positive direction of x-axis. I repeat again here, this is the angle which make the line OP with the positive direction of x-axis. This is called the argument, right? So this is the form which is called the required polar form. But here you see, here this is our system, right? This is right. Previous case we consider this is this way we can just construct. But here you see, if this complex number in this quadrant, then what happened? Then this will be theta and this will be r, right? But the question is that if we use this triangle, then also we can easily find this z equal to r of cos theta plus I of sine theta. This thing we can easily establish, right? But the question is that whether this theta is called argument of this z or not. No, because you must remember this argument means here the angle which make the line OP, whatever we consider this one or this one, this OP line makes the angle with the positive direction of x-axis. Yes, so this will be the actual argument here, right? So first, before this one, just I will rewrite this form. This is here, in place of r we can write here modulus, right? Modulus into cos of argument. So you must remember cos of argument plus sine of argument. You must remember this is the actual form, right? Here theta is nothing, this is the argument in the previous case, right? Here. But here you see this is not the actual argument, right? So now question is that suppose they give some complex number like this way, suppose -1 plus root over 3i. So this is suppose complex number, and we know that this complex number will belong to the second quadrant, because you see the real part is negative here, right? So since here the second quadrant, And now the question is that how we can represent this complex number into polar form, or how we can convert this complex number into polar form, right? So for conversion of this complex number, we need modulus, we need the argument, right? That means we need the formula to find this argument as well as modulus, right? So from this triangle, I think you can easily modulus of this complex number. So what will be this R, guys, from this triangle? Here you see, if we use the Pythagorean theorem, what we get? This hypotenuse equal to perpendicular square plus base square. So this will be x square plus y square. So from here R will be x square plus y square of root over, right? So this is the modulus. Here you see, here we consider only the positive value. Here you see, if we remove this square, then we need to put here plus minus, right? But we consider only the plus one. Why we consider plus one? Because this is the distance from the origin to the point. So, and distance never be negative, so that's why you just consider the positive one only. Is it okay? So this is the formula by which we can easily find the modulus of any complex number, right? So we can easily find the modulus of this complex number, right? But how we can find the argument of this complex number? So here you see, this shows our x, y, this is our x, right? And similarly here will be y, here will be x. So from this figure or this figure, what will be tan theta, guys? You see, what will be tan theta? Tan theta will be here perpendicular by base, that means y upon x. So what will be y? This will be tan inverse of y upon x, right? We can easily find, now guys, you see, we can easily use this formula to find this theta. Now the question is that whether this theta is an argument of this complex number or not. You see here, whether this theta is an argument or not. So just I will consider a numerical example. Suppose we consider 1 plus root over 3i. Okay, this is the complex number. Here you see, here. So this is x, this is y, and here you see xi both are positive. So this complex number will lie this quadrant, right? So what will be theta, guys? So here theta will be tan inverse of root over 3 upon 1. So here tan inverse of this root 3 by 1, root 3, that means tan inverse of root 3. This will be pi upon what? Pi upon 3, right? Pi upon 3 will be there. Is it okay? And here if we consider another complex number, here you see here minus 1 minus of root 3. You see both the values are negative. So this will belongs to or lie in the third quadrant. So in this case also theta will be what? Theta will be root over of minus 3 of minus 1. So this will be tan inverse of root 3. So this will be also pi upon 3. Now you see theta is pi upon 3 here, here also pi upon 3. But in this point or in this complex number, this is the argument, right? And this is pi upon 3. That means this is correct. This will be argument. But here you see in this point or this complex number, what will be the argument? The actual argument will be this one or this one, because we need the angle which make the line OP with the positive direction of x-axis. So whether this is the required argument? No, we need this is argument. But if we use this formula, we'll get this angle only this angle we can easily find, right? This is pi by 3 means this is the angle, right? So if we use this formula, in the first quadrant we will get the actual argument here. This will be the actual argument. But the second quadrant, but the third, fourth quadrant, this value will not be the actual argument. So what will be the argument or actual argument, or how we can easily find this argument? So what we do here, in the second quadrant, we just try to find the argument of z is nothing. You see here, if we use this formula, then we will get this value only, right? But what is the actual argument? This is the actual argument, right? So you see here total is pi, so pi minus theta. So this pi minus theta. So this will be the argument of the complex number which is lie in the second quadrant, right? And in the third quadrant, what will be the argument? Here you see, if we use this formula, we can easily find this theta. Here this will be the theta. So what will be the actual argument? This will be total pi plus theta, right? Pi plus theta. Or this way also we can measure from this side, okay? So this will be the actual argument. So you see the total is pi minus theta. So or we can write pi minus of theta. But you must remember, we just use here clockwise direction, right? So we consider clockwise, so that's why here we need to put minus. So what will be this value? So what will be this value, guys? This will be theta minus of pi. So this is the argument for this complex number which is lie in the third quadrant. Now what will be the argument for this quadrant? Here you see, this is the theta, but here you see this will be the actual argument, but here you see we just calculate by using the by which direction, the clockwise direction, right? So in this case what will be the argument? This theta will not be the actual argument, this will minus theta will be the actual argument, right? Because we use here the clockwise direction. So these are the formulas for argument, and the first quadrant, this is theta, right? Of course this will be theta. So these four formulas are important for argument, right? And hope you can easily remember these formulas, and by using these formulas, right, we can easily find the argument of any complex number, and also we can easily find the modulus by using this formula. Now you see, suppose we have some complex number, suppose z equal to, okay, suppose 1 minus of root 3i. Okay, suppose this is the complex number and we want to find the modulus and argument of this complex number. So what is x here? X is 1, y is minus of root 3. Here you see, x is positive, y is negative. So what will be the quadrant? In which quadrant this complex number will lie? This will lie on the fourth quadrant, right? So from here, what will be the modulus? Modulus of z will be here root over of 1 square plus root over of this one, that means root over of 1 plus 3. So this will be root over of 4, that means 2. So we can easily find the modulus, right? Modulus will be 2 here. But what will be the argument? So here you see, this is x and this is y. So what will be the theta? So theta is nothing, this is tan inverse of y upon x, right? So this is tan inverse of y means minus root 3 upon 1, right? So this is tan inverse of root 3. This is similarly this 5 upon 3. So this is theta. But the complex number lie in the fourth quadrant. So what will be argument? So argument will be here minus of theta, that means minus pi upon 3. So this is the actual argument, right? So hope you can easily find the argument at model. And what will be the polar form? What will be the polar form, guys? So required polar form. What will be the polar form? Z is modulus, right? Modulus cos theta, sorry, cos of argument plus I sine of argument, right? This is the formula. So modulus is 2, cos of theta is minus pi upon 3 plus I sine of minus pi upon 3. So this is the required polar form of the complex number. So hope you can easily find the modulus argument of any complex number, and you can easily convert the given complex number into polar form also. Okay, so this is for today.